Well, now that you have mastered or had some exposure at least to factorials, we're going to see how factorials can be useful to us in other mathematical situations. Today we're talking about binomial expansion, which affectionately we know as superfoil. Okay, it's a kind of an alternate to the somewhat time-consuming process of doing superfoil as the binomials get bigger and bigger and bigger. So let's start by looking at something we defined yesterday. So I want to talk about C00. So as we defined that yesterday, that would be 0 factorial over 0 minus 0 factorial, and then followed by 0 factorial. And as we also talked about, 0 factorial is 1. So this is 1 factorial over 1 factorial, is just 1 over 1 times 1, so 1 overall. And then I want to look at what C10 is, and maybe C11. So C10 would be 1 factorial over 1 minus 0 factorial over 0 factorial, which is also a bunch of 1s, also equal to 1. And here we're going to have the definition 1 factorial over 1 minus 1 factorial over 1 factorial, which is more 1. So how long does this keep lasting? Okay, if we've done the combinations of zeros and we do the combinations of zeros and ones, how about the combinations of 2 with 0? What do we get? All right, well, we're going to get 2 factorial over 2 minus 0 factorial over 0 factorial, which is 2 factorial over 2 factorial times 1, which is still 1. I don't know if you can see where I'm going with this. How far do you have to go to finally get something that is not 1 anymore? So 2 factorial over 2 minus 1 factorial over 1 factorial. Now we have 2 factorial over 1 factorial and another 1 factorial. Now we have our very first time where we do not get 1 as an answer. We get 2. Now, there was a French mathematician named Blaise Pascal, and he was really fascinated by this. And so he kept going, and he did 2, 2. And then he did all the 3s. Okay, well, what about 3, 0, and 3, 1, and 3, 2, and 3, 3? And he noticed that as long as the two numbers were equal, you would get 1, or one of the numbers was 0, you would get 1. So that means this one would be 1 as well. But the other ones would not. You'd get something different. And he tried it with the 4s and the 5s and the 6s, etc. And he started to notice some patterns coming over and over and over as he was doing this. Okay, every time I do it with matching terms, I get 1, or if I do 0, I get 1, but then the other in between ones, I don't. So Pascal took the results of this and he started to arrange them in a triangle. So here there was 1 term, there were 2 here, this was a group of 3, this next one is a group of 4, and he noticed that every time you changed the front number, there would be 1 more combination of how this would work out. And so he, like I said, he started to arrange the results, and he noticed that they formed a triangle shape. So at this point, if you have not yet downloaded the Pascal's triangle worksheet for today, you'll want to do that because we're going to fill that in as part of our notes. All right, so Pascal said, okay, the first one I get 1. Then my next group was a set of 2, and I got double 1s. My next group is a set of 3, which are these one. I get 1, 2, 1. My next group is a set of 4. This turns out to be 3. That turns out to be 3. That's 1, 3, 3, 1. And so like I said, he arranged these in the form of a triangle. And so on your worksheet, you've got these numbers arranged. The first set was a single 1, and then a double set of 1s, and then 1, 2, 1, and then 1, 3, 3, 1. And he kept going, and the next one would start with a 1 and would end with a 1, but then would have 4, and it was 6 and 4. And the next set, it starts with a 1, ends with a 1, then it became 5 and 10 and 10 and 5. You started to notice something about the way these numbers were lining up. So let's take a look at this. Okay, although these numbers are arranged as a triangle, I want to look at some upside down triangles. Let's take a look at this set of numbers here. We have a 1 and a 1 with a base of a 2. 1 plus 1 is 2. I wonder if that keeps working. Can I try a different triangle? Okay, well, how about if I try this one? An upside down triangle. 1 plus 3 is 4. Would it work again? 6 plus 4 is 10. And it does. No matter where you position yourself on this triangle, these numbers, the top two, will add up to the one in the bottom, which is going to help you to continue filling in the rest of this triangle. So this would be a 1. What would the next one be? Well, if I look at what it should be a 6, and it is. And if I look at the next one, it should be a 15, and a 20, and a 15, and a 6, and a 1. And I could fill out the next row. 1 followed by a 7, followed by 21, 35, another 35, a 21, a 7, and a 1. There's symmetry to this. There's patterns to it. And they all match up to the combinations that come from the factorial formulas that we started with yesterday. Okay, no matter what position, they all match up to those factorial formulas. Okay, so let me clean this up a little bit. Let me get rid of my green triangles. All right, so each of these positions matches up. So let me remind you of how this goes. Okay, that guy right there, that was C3, 1. We say that that's the number that is in the third row. Now maybe you're going, wait a minute, that looks like it's the fourth row to me. Okay, this top one is not considered a row, or you can call it the zero, the row 0, okay, but it's not considered row 1. That's row 0. So then we have row 1, row 2. So now we're in row 3, again, position 1. And you might say, well, wait a minute, that's position 2. Again, because the first one is position 0. So we have a row 0 and we have a position 0. So each of these has a formula that goes with it. All right, so let me clean this up a little bit. Okay, so I'll label them all for you. Okay, C, row 3, position 0. That's that number. C, row 3, position 1 is the next one. C, row 3, position 2. That's this one. And the last one would be C, row 3, position 3. So I should be able to point at any number on this Pascal's triangle and ask you what position that is. So for example, let's do this 10 right here. What position is that in? Well, it is in the 5th row, and it is in the, let's count it, 1, 2, 3, 4, but we don't count at the 4th position. You got to say, oh, right, there's a position 0. So that is C5, 3, that position right there. And again, they all come from the factorial position. Okay, how about this 21? Well, that is position from row 7. And then if we count in which position that is, Okay, 0, 0, 1, 2, 3, 4, 5. That is C7, 5. You can fill these in using the addition of the triangles also. 7 plus 21 is 28. 21 plus 35 is 56. 35 and 35 is 70. And then I go back down to 56, 28, 8, and 1. So this is what is called Pascal's triangle. It is infinitely long. It just keeps going and going and going as long as you need it. It comes from the factorial formulas, the C formula for factorials, and it is arranged in such a way that there's tons of patterns that show up in Pascal's triangle. If you notice, all of the ones, of course, are on the outside. Okay, so that's one pattern. Other people notice what happens in this diagonal, that it's 1, 2, 3, 4, 5, 6, 7, 8, which also comes down that one. The next row of this row of numbers matched up to that row of numbers. Those have their own pattern. 1, 3, 6, 10, 15, those are increasing up by 2, up by 3, up by 4, up by 5. Those have their own patterns as well. So all of the, every row's got its own unique pattern that comes up. All right, well, what in the world does that have to do with superfoil? Okay, superfoil is where you take a binomial term, x plus 2y, and expand it. So if we were to do this the long way, the old-fashioned way, x plus 2y multiplied by x plus 2y multiplied by x plus 2y multiplied by x plus 2y. That's what it means to have something to the fourth. Multiply it by itself 4 times. And that superfoil process is very long and laborious. So we can use factorials and Pascal's triangle to help us out with a shortcut of a way to get the answer that's a little bit faster. First of all, we focus in on this number, that 4. That 4 tells me I need to pull all the numbers off of the 4th row of Pascal's triangle. So I'm going to look up the 4th row is this row of numbers right here. Okay, remember there is a row 0, so this is row 4. So I'm going to put those numbers here. 1, 4, 6, 4, 1. Next, I'm going to take the terms of my polynomial, my binomial expansion, which are x and 2y. And I'm going to fill those in this chart in parentheses all the way across. And then 2y would go underneath it. Okay, it's important to use parentheses. Okay. All right, and then actually, let's separate the 2 and the y from itself. Let's do all the 2's and then all the y's. That might be easier. 2, 2, 2, 2, 2, and then y, 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 y. Okay. All right, now we attach powers. On the x, we start with the highest power of 4, and we work our way down. 4, 3, 2, 1, 0. For the 2's, we go the opposite direction because it was after the addition sign. And so we go 0, 1, 2, 3, and 4. And for the y's, we go in the same direction as the 2's because 2 and y were both after the equal sign, or after the addition sign. So 0, 1, 2, 3, and 4. And now you multiply the row down. So I'm going to take all of these numbers and multiply them together. So 1 times x to the 4th times 2 to the 0 times y to the 0. Remember, anything to the 0 is 1 automatically. So I'm going to multiply 1 times 2, x to the 4th times 2 to the 0 times y to the 0. That gives me 1x to the 4th. Then I'm going to do the next column. 4 times x to the third times 2 to the first times y to the first. Okay, 4 times x cubed times 2 times y, that's going to give me 8x cubed y. In the next column, I'll go 6 times x squared times 2 squared times y squared. It's going to be 6 times x squared times 4 times y squared. That'll give me 24x squared y squared. 4 times x to the first times 2 to the third times y cubed. That's 4 times x times 8 times y cubed. That's 32xy cubed. And then finally, the last 1 times x to the 0, which is also 1, times 2 to the fourth, which is 16, times y to the fourth. So I get 16y to the fourth. Add these up, and that's the result of the superfoil. That is the same thing you would get if you superfoiled all of those answers out. So that is the answer. That is the polynomial, degree 4, lead coefficient 1. And that all came from Pascal's triangle. So let's try another one. Okay, the power on this is 5. So I need to use the 5th row. So let's look up, and the 5th row is going to be 1, 5, 10, 10, 5, 1. So I'll use 1, 5, 10, 10, 5, 1. I made these charts probably longer than what you would need, just so you'd have enough space. All right, so we've got 2, 2, 2, 2, 2, 2, and then x, 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 and x. Negative 3, negative 3, negative 3, negative 3, negative 3, and negative 3. And then, oops, I didn't make it long enough. Y, 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 and y. Now we attach our powers. On the 2's, I start with a power of 5 because this is a power of 5 problem. And we work our way down. 5, 4, 3, 2, 1, end at 0. With the x's, I also go 5, 4, 3 because it's in front of the subtraction. So 5, 4, 3, 2, 1, 0. For the negative 3's, I go up. So 0, 1, 2, 3, 4, and 5. And for the y's, I also go the same direction. 0, 1, 2, 3, 4, and 5. Okay, now I'm ready to multiply them all together. So 1 times 2 to the 5th, times x to the 5th, times negative 3 to the 0, which is 1, and times y to the 0, which is 1. So multiplying all of that together, I get 32x to the 5th. All right, the next column, we work our way down. 5 times 2 to the 4th. By the way, 2 to the 4th is 16. Times x to the 4th, times negative 3 to the 1st, times y to the 1st. Okay, all of that together. 5 times 2 to the 4th, that's 5 times 16, it's 80. X to the 4th times negative 3. Altogether, we get negative, I better change my color here, negative 240 x to the 4th y. Okay, the next column, we're going to work our way down. Here's where you got to watch out. This is the first place lots of people make a mistake. Negative 3 squared. That means negative 3 times negative 3. So negative 3 times itself, which is also negative 3, is going to be positive 9. A lot of people will miss that, and they think that it's negative 9. That is positive 9 in that section. So just keep that in mind, that that number is positive 9. This is positive 8. So we've got 10 times 8 times x cubed times positive 9 times y to the 2nd. That's positive 720 x cubed y squared. The next column, 10 times 2 squared, which is 4, times x squared times negative 3 cubed, which is negative 27, and then times y cubed. So 10 times 4 is 40. Work your way down, times negative 27. We're going to get negative 1080 x squared y cubed. All right, now next one, 5 times 2, that's 10, times x, times negative 3 to the 4th. There's another time where you've got to watch it. Negative 3 to the 4th is positive 81 times y to the 4th. So multiplying all that together, we get positive 810 xy to the 4th. And then finally the last one, 1 times 2 to the 0, which is 1, times x to the 0, which is also 1, times negative 3 to the 5th, which is negative 243, times y to the 5th. So we get negative 243 y to the 5th. So let's look at the overall answer. It should alternate in sign. It should be a positive and a negative and a positive and a negative and a positive and a negative. So just double checking that, and that did work out for us. So I start with positive 32x to the 5th minus 240x to the 4th. Now I've got to insert a plus sign right here. Positive 720x cubed y squared minus 1080. Insert a positive here, and we have our final answer. Way faster and way less chances of making mistakes than the whole process of superfoil, trust me. Now, you're not always asked to do the whole thing. Sometimes you're just asked to do part of it. So for example, let me give you a question. So something like, what would be the, say, 6th term in the following expansion, x minus 5 to the 9th. And so they're not asking you to do the whole thing. They're just asking you, if you were to make a chart, just focus on the 6th column in the chart. Not the whole thing, just the 6th column. So you don't have to work out the entire thing, you just have to work out part of it. Okay, well we need the 9th, to start with, the 9th row of the Pascal triangle. So let's look up. We don't have the 9th row yet. We haven't filled it in. So the 9th row would be 1, let's do it in red, 1, followed by 9. Okay, then we add 8 and 28 together, we get 36. And then you add 28 and 56, you get 84. And you add the next two, you get 126, 126, 84, 36, 9, and 1. So it's the 9th row that we need. Of the 9th row, we need the number that would make the 6th column in our chart. So if I just kind of count them out here, 1, 2, 3, okay, so 126. So maybe you want to write those. It would be 1, 9, 36, 84, 126, and then 126 again. So it's going to be whatever's in this column right here to find the 6th term. So that would mean I would have, x, 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 x. I would get to x here, and I would have negative 5, negative 5, negative 5, negative 5, negative 5, and negative 5. Now let's track the powers. The x power should start with 9, and 8, 7, 6, 5. So this will end up to be x4. And the 5s, negative 5, should go the opposite direction. 0, 1, 2, 3, 4, 5. So the combination of all of that the multiplication from 126 down to x to the 4th down to negative 5 to the 5th, and you want to figure out what that's going to be. Okay, negative 5 to the 5th should be a negative number, so it's negative 3125. Multiply that by 126. So my overall answer is negative 393,750 x to the 4th. That would be the 6th term in that binomial expansion. So I didn't have to do the whole thing. I just had to go out to the 6th, imagining that I was using a chart. I made extra charts for you on when you download your worksheet that you're taking notes on right now. There are more pages that are blank, and so feel free to copy those and use those for your homework. Let's do one more example. And so let's find the coefficient, and let's do it on the term of x to the 5th for the binomial expansion 2x minus 1 to the 10th. So again, we don't have to do the whole thing. We just have to go far enough that we can find out the x to the 5th. All right, looking at this, we have the 10th, which means we need the 10th row. We haven't done the 10th row yet, so let's add that to our notes. That would be 1, 10, or you know what we could do? So we could use the formula. Let's do that. In C, the 10th row, okay, I'll be going out to the 10th row, and I need to find x to the 5th. So that would be the 5th term. So I could figure that out. That would be 10 factorial over 10 minus 5 factorial, 5 factorial. So either you can work out Pascal's triangle, and you can do all those numbers and count them over, or you can do it this way. So this would be 10 factorial over 5 factorial over 5 factorial again. So let's remember how that goes. 10 factorial is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 5 factorial, 1, 2, 3, 4, 5, and then start over with 1, 2, 3, 4, and 5 again. So the first set of 1 through 5 are all going to cancel out, and then I can start reducing. I've got 2 and 3 in the bottom here. That's 6, so they can reduce that 6. I've got 4, which can reduce 8. I've got 5, which can reduce 10, leaving me with 2. So altogether, I'm really just left with a 7 times a 2 times a 9 times a 2. So 7 times 2 is 14, 9 times 2 is 18. We're looking at 14 times 18, which is 252. So if I had done Pascal's triangle, I would have gotten myself to 252 also, which would have been this term right here, forming the triangle between those three numbers. So 252. Okay, so 252, but I want the x5 number, so x would start with 10. I want it in white. x10, x9, x8, x7, x6, x5 with a 252 above it. And then the negative ones. Oh, and I forgot the 2's. 2, 2, 2, 2, 2, 2. That would also have a 5 on it because that's coming from 2x. And then negative 1, negative 1, negative 1, negative 1, negative 1, negative 1, negative 1. Those would go the opposite direction. So it would be 0, 1, 2, 3, 4, 5. So combining all of this together, combining the 252 with the x to the 5th, with the 2 to the 5th, with the negative 1 to the 5th, putting all of that together. 2 to the 5th is 32. Negative 1 to the 5th is a negative number. So we end up with negative 8, 0, 6, 4, and the x to the 5th is the only variable left. So the coefficient on x to the 5th is negative 8,064. So I didn't have to do the whole thing, but I had to do enough of it. That helped me figure out what the coefficient on that term would be. So here's one use of factorials and how they can help us to a shortcut of binomial expansion. I hope this goes well for you. Feel free to jump on in a Zoom if you're having trouble with any of these things. All right, I will check in with you guys tomorrow.